All right, we are back with another part of our own programming language, our own compiler. So, what are we going to do today? I think what I want to do is get variable assignment, right? So this is kind of our language so far. Maybe we'll get syntax highlighting at some point. But we have if statements, else. We can assign variables, we got expressions, we got multi-line comments, single-line comments, and all that. And so we can assign variables like let x equals 1, and then we can print out x here, so we can just make this 7, and then if 1, which is true, so this should exit 7. So we can go ahead and test that and make sure it all works. So we can go ahead and run our compiler on this file here, and then go ahead and run it. Actually, let's do that all at once, so then we can do let's see, /out, and then echo the exit code. And we get 7, which all makes sense. But what we can't do is say x equals 5, right? That does not work, right? We don't have variable assignment yet. So that's what I think we'll add today. So now I do have the word let here. I kind of like the idea of immutability by default, but I don't think I'm going to worry about that for now. Maybe we'll get to it, but we'll just say we can assign these for now. We'll just let them be mutable. So first, we got to take a look at our grammar and figure that out and wonder why this isn't working. Oh, VS Code. Oh, come on. There we go. All right, we're getting there. Starting up. All right. So we can allow another statement here essentially, and what we want to allow is identifier equals expression without the let. So that's pretty easy. We can just go ahead and add that in as some kind of statement we can have, right? So we can have some type of identifier equal to some sort of expression. So we can have text, and then we can have an expression. I think that should do it, right? So identifier equals expression. All right, so that's pretty easy. So now we can go ahead and go into our, so we don't need to mess with our tokenizer because these are all valid tokens that we already have. We already can tokenize an identifier, an equal sign, and an expression, and a semicolon. So we just need to parse them now. So inside of here, these are our different abstract syntax tree nodes. And so we have our statement here, which is a variant between these 4 different types of statements, 1, 2, 3, 4, but now we're adding a 5th one here. So we're going to go ahead and add another one, and so we'll call this node statement assign. I think that'll be good. And so we need the identifier, so that I think it's just a token, right? We start off with a token. Yeah, the identifier is a token. So we can go in here and put in our identifier, and then we need the expression. So node expression. And so now we can allow this to be a valid statement. And I think last time I said that I want to use using instead of like type aliases instead of this like single member struct, but actually I can't do that. Like kind of what I wanted to do was say a statement can be like a variant like this. The problem is I need things to be forward declared. There's kind of like this cyclical referencing thing kind of going on here where I have this like forward declared node statement that I then use, and I can use it even though it's incomplete because I'm just using the pointer for it. But I can't forward declare a type alias where the type alias also has the types that also need to reference the node statement itself. So it becomes a cycle that you can't quite deal with, at least in a way that is simple enough for me to implement. I don't know, maybe there's an easy way around it. I didn't see anything too easy other than just having a single member struct and calling it good enough. And remember, we're just bootstrapping our language in C++. Maybe we'll be able to actually write this language in itself. So in this case, we can completely ignore C++. So okay, so now we have a node statement here, but now we need to parse it. So there's a method in our parser for parse statement, And in here, we have the different types here. So we have like an exit here, and then we have the let, and then we'll do this third. We'll just keep it in order here. So, so we'll go in here. And so in order for this to parse correctly, we need to start with an identifier and an equal sign, right? So if we start with an identifier and an equal sign, then that means that we're doing some sort of assignment. Now, because only one of these starts with an identifier, we could, I guess, start with just saying we have an identifier, but I'd rather get all of our terminals, like parse all the terminals before we have to parse another node. So terminals are essentially the tokens, meaning that it's not a node that goes somewhere else. So like here, this is not a terminal because it's an expression that can become something else. So terminals are things like this slash, this plus, an integer literal, an equal sign. Those are all terminals. So I want to make sure I parse all the terminals I can until I throw an error when I can't parse an expression. So, and if you're curious about where like something like ambiguity would come up, is that if I were to have like an identifier and then an equal sign, another one in here, but with a different node after it. In that case, I wouldn't be able to really tell which one is which without some more kind of trial and error, which is not something I want to deal with. So let's go ahead and get in here. So this just needs an F actually, and I want it to be below here. Oh, I forgot. Yep. So we're here. So we need to make sure that we have a next token. So if we peek the next token and it has a value, and then that token's value type equals token type identifier, right? And then we want it to be, we need to check the next token too. So then we need to peek 1. So peek, by default, we'll just have an offset of 0, so it will peek the next token. So peek 1 will peek the token after that. So we have an identifier, and then we want to make sure that there is a token after that, because we might be at the end of file. And if it exists, and its value type is token type equals, that means that we're just going to assume, okay, you're trying to do some sort of assignment, and so at this point, if we fail to parse anything while we're inside of this scope here, then we throw an error, right? So in that case, we want to parse an expression. So first, we need to actually allocate our AST node, so that way we can put the expression inside of it. I guess we could allocate it before or after we parse the expression, it doesn't really matter, but we've been allocating it beforehand, so we'll just continue that. So we, in this case, we have the assignment, and then we will we'll call our allocator, which is an arena allocator, and we will allocate the node statement assign in here. And right now that's just empty, and so in here we need to give it the identifier and an expression. So actually, we do need to we didn't consume our tokens, actually. So what we need to do is we need to actually set our identifier equal to the token we consume. So we peeked the first token, and we know it's an identifier. So that means when we consume it, we'll set that identifier in here, which will be used for when we generate the code, right? And then what we want to do is we want to consume the equal sign, but we don't need to store it anywhere. That's just useful for parsing. It's not actually going to be used during code generation. We don't need the equal sign there. So now we consumed the identifier, we consumed the equal sign, and now we need to parse for an expression. But there might be a certain situation where you don't have an expression because you screwed up, right? You can write an invalid program, so we need to account for that. So we need to say if auto like expression equals parse expression, and each of these parse methods returns an optional, where if they don't parse correctly, then they will return an empty optional. So when we do this, this is essentially saying that if the expression has a value, then we want to assign it to our assignment node, right? So we're going to put it in there. Else, this is where we can throw an error. So we can go ahead and do 0. We don't have like a utility function for this yet. Maybe we should at some point, but we'll just put expected expression, right? And then we can go ahead and exit with exit failure, which is just macro 2-1, just saying it fails. And so oh, we need to actually set this to actually, why is this working? Because this is an optional. But this is not optional. Oh, I don't actually assign it. Equals expression.value. That was interesting. And this can be made const, yep. Which means this should... Oh, this can be made const, actually, yeah, because this is a pointer. So the pointer is const, but not what it's pointing to. So the pointer is const, but the thing that it points to is not const. So that means we can assign the members, right? But not the actual variable itself. All right, so now we got that, but we're not done yet because we need the semicolon. So we need to check after the expression is parsed. We need to make sure there's a semicolon. So we need to try consume, and we can give it a token type. So this will try and consume a specific type of token, and then we can give it an error message so that if it's not a semicolon, then we can throw an error and it will go ahead and exit. So expected semicolon. All right, and now we got to actually return our statement. So that means we need to allocate our sum type, which is our node statement, and then assign the assignment to that sum type, which is our variant. So we can go ahead and do statement equals allocator, and we can do in place, so we can pass something to the constructor, node statement, and we can pass in the assignment. And now we can go ahead and return our statement from here because we are inside of the parse statement here. All right, so that should take care of parsing. So if we try and build this, actually compile the compiler itself, we should get an error because we don't actually, during code generation, we try and call a visitor to visit all the different types, essentially a match statement, an exhaustive match on our variant, and it will not compile if we don't match everything. So in this case, we need to actually deal with code generation. So we in order to do that, we overload the parentheses operator or the calling operator, however you want to call it, with the correct type. Right? All right, and so now we need to deal with code generation. So in order to assign a variable, we have to make sure it exists, right? And so it's been a bit, so I don't quite remember what we're actually keeping track of here. But it looks like for our variables, we actually have it in a vector, right? So we need to check if it's inside of the vector, right? And then our variable in here has is a struct which has the name and then its location on the stack. So if we verify that it exists, then we know where on the stack we should place that value that we get from the expression. So first we need to make sure it exists. So I think what we can do is use one of these like this new like ranges thing. So std ranges find if, and then we can do take our variables and then we can give it a lambda, right? And then, oh, actually we need to do gen vars, yeah, or dot, because it's a reference. Okay, so the generator, which essentially gen is just this, because it's in a struct, I just pass this into it. So that's how I access the members here. And so we're trying to find a variable. So we need to loop through all of our variables here. And we need to say, we need to return true if the variable name equals the statement assign identifier value dot value. Because, so this is the identifier, and the identifier has an optional string because it's just a token, and a token has an optional string. Now, it should have, it should always have a value. Right, so we could assert that, but it should have a value. And then actually we don't need an if here. We just need to return that these are equal inside of this lambda here. And we have an issue, so it's not captured. Right, so we could just capture everything in here. So now what this will do is it's going to loop through everything in our variables here, and then it's going to check if the name equals the variable the identifier of the variable we're trying to assign, and this will return an iterator. So we'll get an iterator from that, and so if it doesn't find it, then that iterator will be equal to mvars.end, right? So if it's equal to the end, which is one past the array or the vector, because that's how C++ works, we can make this const. If that's the case, then we need to throw an error because we don't have that variable. Essentially, we didn't find it because we went through the whole vector, and now we're one past it. So we didn't find it. So we can go ahead and throw an error here. So we can see error. What kind of message should we have? I guess we can have undeclared or undefined identifier, undeclared identifier. We'll just put undeclared identifier for now. And we'll specify what that is for now. Again, we should fix these error messages with actual line numbers and stuff and all that, but for now we'll just do this, and then we'll say statement assign identifier value. Throw an end line there, and then we'll exit with exit failure. All right. So we did that. So now, once we get to this point, we know that we have the variable. It does actually exist, and we're not checking for types. Everything's just integers for now, so we don't need to worry about the type. So now we need to actually we actually need to evaluate the expression, right? Because if we go to our code, our expression is just a number right here, 5, but we could have something like 5 plus 10. In that case, we need to evaluate that expression and take the value of it, right? And put it in a register so that we can assign it to that specific location that X represents on the stack. So we need to go ahead and evaluate the expression. So we need to generate expression. Actually, we need to gen.gen expression and pass it our statement assign dot expression, just like that. And so now what this generate expression will do, it will create assembly that puts the result of this expression on the top of the stack, right? That's something that we guaranteed by the way that we programmed this. So in order to get the value out so that we can put it into the right place, I guess we could, I don't know if we need to put it in a register first and then put it somewhere else, move it to the place on the stack, or maybe do it directly from one location on the stack to another location on the stack. You might be able to do that. I'm not really sure, but just to keep things safe for now, I know for sure you can move something from the stack onto a register, and then from the register back onto the stack. So we'll just do that for now. Again, we can do optimizations later, but that seems the most straightforward. So we'll do gen.pop into racks. So we're going to put the result of this expression in racks, and now we need to actually assign the variable. And I gotta be honest, I can't quite remember how I did that, so I'm just going to copy what I had up here, which looks like how did I do this? Oh, okay. Maybe I didn't do that up here. No. Okay. All right, so I think I'm going to have to do something a little bit. Let's see how I remember to do this. So I think if I take a look at this assembly, we need to move. Okay. So push something onto the stack. So we need to copy something from a register onto the stack. So how would you really do that? I guess you would need like a move into. Well, you would need to move it into some kind of offset from the stack pointer, I guess. Yeah. And I wonder if we need to specify the size of it too. So we would have to do something like this, I think. And then the actual value, so like racks, I think. And then this would be the offset as to how deep in the stack the variable is located in. Yes. Something like that. Let me take a look. Actually, maybe we can take a look at where we like access variables. So that would be in our gen expression to get kind of a refresher on how we did that. So this is the exact same kind of thing. Yeah, okay, so this is how we get this location on the stack. So we'll copy that and get back over here. So what we can do, and we can append to our output here, or stream into our output. We want to move, and what do we have here? Okay, so we need like RSP plus, and then whatever this value is. So this takes the current stack size minus the stack location of our variable. And then we got to offset it by 1 because off by 1 somehow. And then we multiply it by 8 because there's 8 bytes. Because we're doing everything in 64-bit integers. And then what we can do is, how does our assembly look? We need a comma, and then we need racks. And then new line. Right. I believe so. We don't need a space there. Is that right? I'm not much of an assembly guy, even though that's what I'm making a compiler. So again, this is also for my educational experience as well. So I could be completely off here. Okay, so it built here, so that means that the compiler compiled, but now does our application compile? Oh, well that's surprising. Does this actually just work? Oh look, 15. Wow. Now what would happen if we do something interesting like set it to itself? Now this should not do anything. X equals X should not this should be valid, but it shouldn't do anything, right? This should still exit with 7, and it still exits with 7. And if we look at our assembly, because we're not doing any kind of optimizations, we should see that like redundant X equals X somewhere, which if we go over here, yeah, if we push the value, pop it, and then move it back in here. So this is just like a nothing. Like this does absolutely like nothing, but you know, it's just doing literally what this code says, right? So that's cool. So I believe I had a logic error in this if else on how I generated it. I think I went back after the video and I think I fixed it. But I'm not 100% sure, and it's hard to tell because we only had exits here, which meant that there wasn't a good way of testing this very well. So I think what I'll do is I can test this by assigning values in here. So I can have this be x equals 1, x equals 2, and then x equals 3. All right. And so now we can actually see what path it goes down. So in this case, we should exit with 1 because this is going to be true, and then that means that these should no longer run. And so if we run it, we get 1. Oh, but we forgot a semicolon. Look at that. Okay. Ooh. That isn't right. So it did do this elif here. Yeah, so I do have something wrong with my if statement code generation. Or my like if else kind of thing. So it would be gen statement. Let's see, it would be in here somewhere. We need to go to where the if is, and I have like so we have the scope, and then we jump to our label. Ah. Okay, I see here. So we need to put... I think I need to create the label. I think I just need to put this down here. And jump label. Maybe well, I only need to jump. So what I'm doing here is this is the if. This is checking if it jump if 0. So jump if false past the if, which should be Yeah, so I did need that label up here. And then if we execute the after the if, ooh. Well, we only need to jump. So if the if is true, and there is an else if or an else, that means that we need to then jump past all of those things to the end. But if there is no predicate, like if there is no else or else if, we don't need to do that. So we only need this jump if it has a predicate, right? So we only need a jump if there's a predicate, and we actually need to have that be like a label it goes to. Of course, this is now in the wrong place, because this label needs to be here, and then this, and then we need like the end label here. Okay, so what I think I need to do is I need to like lift this out of here. And because I have this strange situation here, I think I need to make this optional. And then say that end label equals this, and then we'll say dot value, and it has to have a value over here. And I think that should do it. Let's see. That still gives us a 2. Okay, so I really am screwing things up, so that means that I need to look in the assembly and see actually what's going on here. So also I added like these comments that get generated for these things here. So where's our if here? So let's put our assembly next to our actual code to see what exactly is wrong here. So we have our if, so we move 1, and then we test. In this case, it's true, so it's not going to jump. And so it's going to say x equal to 1, which is going to do here, and then it should jump to label 0. But it shouldn't jump to label 0, it should jump to the end label. All right. So that means that, yes, this needs to be end label. Yep, that was a little mistake in there. Ooh, oh, and this needs to be dot value. All right, of course. So we can go ahead and do that, and that works. All right, this looks, I don't actually like how this is done. I'm gonna see, maybe I should just do this. Maybe I should keep this in here. Keep this over here. Yeah, and then put like an else over here. I think this will do the same thing. And then we put like this over here. All right, rename local variable. Oh, we can get rid of this then. I think this will just do the same thing, but that looks a lot better. Let's make sure. And then go through kind of just some test cases here. So we get a 1 here, which is right. All right, beautiful, beautiful, beautiful. So now this is going to be false, but then this first else if is going to be true. So now it should give us a 2, which we get. And then this is going to be false. So now both of these are false. So now we should get a 3. Beautiful. All right, so we fixed that logic error here with the jumping here. So if we want to look at how this works with the comments now, it should be a lot more straightforward. So this slash means that it's the end of something, right? So this is the beginning of the if. So let's take a look at our code here. So we move 0 into racks, which is the A register, and then we push it onto the stack to immediately pop it, because that's just how our code works for now. We test it, and then we jump if that test is 0. So in this case, it's 0, which means it's false. So we're going to jump past all of this code to label 0, and this code is where it sets x equal to 1, which we want to skip that because it's false. And this enters our first elif. In this case, this is also false, but we need to check this. We move 0 into racks, push pop it, test it, jump if 0. In this case, it is 0, so we jump to label 2, skipping past x equals 2, which is what this is. So we jump to label 2, into our else, And in this case, our else doesn't have any expression to evaluate, so we'll just execute this, which will move 3 into racks, push racks, pop racks, and then put that into our variable here, which is x. And then we'll just fall through down to here. In this case, that's the end of our if here. We skipped all of this, and now we just exit. We call this exit here, so we take whatever's in x, which is RSP plus 0, and then we do the syscall to exit. And then this will never happen. This is just the exit code of 0 in case we don't explicitly call exit. Beautiful. So that all seems to make sense. So I think that is good, and we should go ahead and commit these changes here. So let's just do a quick sanity check, make sure all of this makes sense. Find F7 on my keyboard to just make sure all these changes are good. That change in our grammar, yep. We added these things, added that, and we did all these little changes to just our test code. All right, that seems to fix it. So what did we just add? Add assignment. I think adding immutability would be good, like having it be immutable, unless you add like a certain other keyword to it. I won't mention what that is. Maybe something like, maybe like can be changed. Let can be changed x. Oh, that would be good. That'd be good. All right. What do we do now? What do we do now? I think we should deal with these horrible error messages, because if we make a mistake like missing a semicolon here, expected semicolon, but where? It doesn't tell us. So at least having a line number, I think, would be good. So in that case, we actually need to then store the line numbers in a lot of places. Maybe even the column it's on. So not only line number, but column, meaning that it should be like, I don't know if my camera is covering it up, but you can see down here, line and column. So in this case, it should give me 710, right? Or 711, however. You want to do that. And so we need to keep track of it. So let's go ahead and do this as a test. And so in order to do that, we need to keep, in our tokens, I think we need to keep track of, in our tokens here, we need to keep track of the line number and column as well. So I think what we'll need is int line, int col, right? And so then when we parse and when we tokenize, we need to actually keep track of the line number we're on. Now that's a pretty simple thing, because keeping track of line number is essentially counting how many new lines we come across, right? So we're going to need to have some sort of count, like line count, and line count, and we're going to start at 0. And anytime there is a new line, we want to make sure to increment that. In this case, I don't think we're ever explicitly checking for a new line, so we need to do that. So we need to do else if peak value, and now this peak is peaking for characters, not tokens. And if we have a new line, then we want to consume that new line and push. Oh, we don't need to push back a token. What we need to do is do line count plus plus. All right. So. And then maybe we should have a better error message here. Invalid token. All right. Oh. Okay. It looks like in our parser we do some kind of... maybe I could just do this for now over here. Oh, I can't do that. I don't know why I made this a structured binding. Oh, there we go. That'll silence that. But this should compile now. Cool. So that means that anytime we push back a token, we need to push back the token type and optional value. Oh, see, that's an optional. So what I think I should do instead is put the optional thing last, That would make much more sense. So in that case, now that's going to screw some things up. But now we can put line count. And we also need like a column count. Ooh, that's kind of annoying. You know what? Forget about columns for now. Let's just do lines. That'll just be easier. I think that'll be fine for now. So we can give it the line count. And so everywhere we push back a token, we need to add that. Right. Oh, am I going to need to put... Ooh. You know what? I think I'm going to have to... I think I'll get rid of this dot type. I think it's pretty self-explanatory what's going on here. Okay. Paste that in. Get rid of this. Alright, so I think I got that on everything. So if I go ahead and run this, we should get, yeah, something by our I don't know why I did a structure binding here. I think because CLion told me I should, and I believed it. And then value. I think we'll fix that. So I think this will work now. So this should still function the same. Yeah. But now, anywhere we have like an expected, which is in our parser. So we have like expected. So I think what we should have is like a utility function that actually produces an error at like a location, right? So maybe we should call it, what do we call it? So this will be void. Maybe we do error. Since we have so many like expected, we'll do error expected. And then we'll have like the token we expect. Like, or the character we expect. Oh, we can't do that. And then we can do the location we expect it to be in, like the line. So then we could do C error, and we could do, why don't we have this? Do I not? Don't I do C error in here? Yeah. Interesting. Huh. Am I, like, typing this wrong? Okay. We'll do, like, parse error, parser error, parse error, expected, and then we can put in our character, on line, and then we can put the line number. We can end line here, and then return. Oh no, we need to exit failure. Wait, what is going on here? Have I like, can be made static? Yeah, it can be made static. Oh, well there we go. Yeah, something was going wrong here. Cool. So now anywhere we have expected, so we expected an expression here. So, like, over here, we can do... Ooh, see, this is expected expression. Maybe we should have... Maybe we just have a message here, and then have this be a message. Alright, so we can do error expected, and then we can do expression. And then on line number, how do we do this? Huh. I guess it would be the line that we have the open parenthesis on, yeah. Because this is doing like a term, I guess. Open paren dot, value dot line. Yeah, there we go. All right. So I should do that. We make that const. Beautiful. And then we have this over here, close paren. So we have expected. Okay, so try consume. So maybe in here we should just call, like, we'll make this a message. And we'll do error expected message on line. I guess we could do line. I guess we'd have to have a line here, which means we need to pass in the line over here. It's gonna break some things. Right. Add return statement. Ah. Well, this will throw an error. This exits. So, oof. I guess CLion can't really see that. I guess we can disable it with a comment. Or can I just return, like, nothing? Alright, that'll work. Cool, cool, cool. Alright, where's the next thing? Where are our errors here? Okay. So we have this try consume, and then that, and then we need a line number. So I guess we'll assume that this is on the same line as this, as the open parenthesis. Something like that. Yeah. Okay. Unable to parse expression here. Okay. So I guess we do expect error expected. We expected an expression on line number line. Beautiful. All right, so this is seeming like it's making sense. So try consume this on line number. I guess it's, let's see. So we're parsing the scope here, and we're looking for the end of the scope. Ooh. So I guess it would be the line after the last statement here. So maybe we need to keep track of, like, last statement line. And so we could do last statement line equals statement dot value dot. Oh, wait. Oh, this isn't a token. This is an AST node. Ooh. Because AST nodes don't have line numbers associated with them, do they? Or you know what? I can just use whatever token we're at. Right? So we can just do so we need to make sure that I guess I could do like peak. So this is size T. I actually don't know if I like this being size T. I think I want to make this an integer because I want to go backwards. Dot value dot line. I think that's right. I don't know. We'll find out. Oh man, this is why error messages suck so often, because they're hard to program. They're hard to program. Let's try consume this open parenthesis. Ugh, this is something's telling me that I'm not really liking how this is working. Maybe this try consume shouldn't take in a line. Maybe we should just be able to peek at -1 value dot line. And then like, yeah, maybe it should be something like that. All right. And now we have expected expression. Okay, error expected expression. And then on line number. I don't know what line number. Maybe we can do the same thing up here. Instead of passing in the line, we just do peak -1 value dot line. And then not make this static. Make that const. And so get rid of this line. Maybe that'll do it. So essentially we peak the token before it. Maybe we need to add 1 to it. But we'll find out, I guess. So expected expression, okay. There we go. Expected scope. Scope. We can get rid of that. Error expected scope. You know, for these try consume, I should have a function that just takes in the token type and gives me out this string. That's probably what I should do next. Right? Otherwise we have this duplicated, like it's a semicolon and then I have to put in the semicolon, which seems a bit stupid. Expected expression. Maybe I should control F for exit failure. Like I should, yeah. Error expected. Okay, so I went through everything and I think it should work. Okay, parse error expected. Expected. Okay, so I screwed that up somewhere. Yeah. Oh, there's a lot of places that this happens. Oopsies. Yeah, I need to get rid of that. Let's see. So, expected semicolon on line 6. Is that the right line? No. Ooh, because we start at 1. Yeah, there's no line 0. So we start at 1, actually. Ah, so that means that in our tokenizer, we just, instead of starting at 0, we need to start at 1. Right. Expected semicolon on line 7. Well, that is a significant improvement from just expected semicolon. But if I do something else, like forget it over here, on line 9. Alright, beautiful. What happens if I forget to end the scope there? That's one that I wasn't sure. Oh, we just get like a complete... Like, it just breaks. Well, that's not supposed to happen. Let's debug that. And I had to reset this. So that means that I can't debug it properly right now. Which means I need to do, like, test.hy and set the working directory to here. Right. And I think that means that I can click run and it would actually compile it. Yeah. So now I can debug and figure out where that is. Because that's strange. Parse statement. If peak value dot type equals exit and peak 1 has value. Oh. I don't check if it has a value at first, do I? If peak dot has value and like that, right? Yeah, on line 12. Okay, so put it here. Well, that's not quite what I was looking for. Oh, you know what? It probably expects it to be like here, doesn't it? See, there is no really good way. Like, it wouldn't know to place it here because it's not looking at white space, because white space doesn't matter. So, yeah. So it would make sense for it to look for it over here, I guess. Yeah, that's a little bit not great, but I think we'll just call it good enough for now. Expected scope on line 8. Yeah, okay. If I do something else, I don't know, make some other really weird mistake. Like, let's put 2 minus signs next to each other. Like, what do we get? Oh, I don't need to keep building this. I can just keep compiling it. Expected expression on line 1. Yeah, because it failed to parse the expression properly. What if I do this? Expected on line 1? Okay, that makes sense. Okay, this is a huge improvement for a pretty, like, very simple implementation of like an error messaging thing. I think these messages are significantly better, right? So that's pretty cool. So I think we can go ahead and push that. Well, actually, I do kind of want to fix this, like, try consume. I think I want a way to convert the token type to its string representation. I don't know, maybe I have that already, do I? Do I have like a toString on it? No, I guess I do not. Right, so I think what I can do is have an inline. Let's do a string because it might be multiple characters for some things, like a plus equals or something. So we'll do a string, and we'll do like toString for the token type. Right. And so now we need to switch on the type, and we need to make sure we get everything. And so now we need to return, yeah, so now we needed to convert all of these to strings, which is just a process. Ooh, this integer literal. I guess I could put int literal, like actually spelled out. Yeah. That one might be a little bit interesting. But close parenthesis. Maybe what I should do is put the like the quotes or the backticks around in here. That way I don't have backticks surrounding these when I call toString in the error message. I think that actually does make sense. Yeah, because int literal, it's not like you should have the actual words int literal in your code, but you should have like an actual semicolon. But you shouldn't have the exact word identifier, but you should have the exact keyword let. So like the backticks indicate that you need to like literally put the plus sign in or something like that, right? Or literally put the star in, right? So I think that makes sense to do that in here. Okay, so that all works, and then we just need to assert false here in case we don't get through all those. All right. I wish I could like statically assert that I like exhaustively check all these. Maybe there's some like like fancy templating magic I could do to figure that out, but I'm not going to deal with that. So try consume, so we don't need this message here anymore. And instead what we do is a toString on the type here. Yes, that is how we should do that. Why does this break now? Oh, because now it clashes with this. So this is try consume. So this should be try consume error. And this is try consume optional. Yeah. So that means that this needs to be try consume error. I see. Okay, so I think I got all that fixed up. So we can now test if, things still continue to work. So we can go ahead and remove that. And we get expected semicolon. If I just get rid of that, it should expect an expression. Expected expression on line 5. Cool, cool, cool. Put that back. If I forget a parenthesis here, expected close parenthesis on line 4. Beautiful, beautiful, beautiful. If I forget, like, I don't even know. Ending brace over here. Expected on line 7. Yeah, I mean, that does make sense because you could put it here. So that's, like, something that could be a thing. So that's understandable. Alright. I think that actually works out. So now I think we can go ahead and commit this. So let's just take a look at our changes, make sure everything looks like it makes sense. Yep. This all looks good. I just want to make sure, like, sometimes I, like, put in, like, print debugging kind of things, or just, like, little things here and there just to test, and I don't remember, and I commit them accidentally, so just going and checking everything explicitly makes me just, like, do a quick look over before I, commit something stupid. Not that I could revert it, but, like, I guess check it beforehand. So we'll go ahead and improve error messages with line numbers. Or maybe we'll do add line numbers to errors. I think that's more concise. So go ahead and push that, and it's been pretty much exactly an hour in my time, I think, before I cut things out. So I think I'll just call it here. I think we made some decent progress. So I'm pretty happy with this. So I think we'll end it for today. So I will see you guys in the next one.